Assalamu alaikum dear students. Bismillahirrahmanirrahim. Welcome you in lecture 11. Clear? In this lecture inshallah we will uh, analyze another cantilever beam, but the loading you see there is a different type of loading. This is, you can say, a uniformly varying load, and you see the beam is cantilever, this is an cantilever beam. We will already analyze a cantilever beam for UDL, point load, and moment. So this is a different example. Clear? So let's see how we will develop this. Okay, through grid line spacing. Clear? So you must ensure about the units, that is kilonewton and meter. So kilonewton and meter we need to select it. Clear? There you can select kilonewton meter, new template, grid only. Clear? So if you look to this example, if you look to this example, you will this is okay. So let's see that how we will assign the grid lines for this structure. Clear? So if I make a 3D view of this beam, clear, a 3D view of this beam, so, and I want to compare this beam with a box, so I have one axis x1 and one axis x2. This is x2 and this is x1, and similarly I have one axis y1 and one axis y2. Clear? And similarly in vertical direction I have one axis z1 and one axis z2. So number of grid lines, basically in x direction I have 2, 1, 2. In y direction I have 1, 2. Although in y direction we have only one axis, so just you can insert one or two, both. Okay. And in z direction we have only in z direction basically we need draw just a line element, not a 2D element. Okay. So because we don't know about the height of this beam, okay, and we don't need the height of this beam. Clear? So therefore we will just drawing a line object. So for line object you don't need two axes z1 and z2. Clear? So this is z1 and this line is basically z2. Clear? This line, okay, this line is basically z1 and this is z2. Okay, this is not okay, this is not z1 z2. Okay, this is z1 and z2. So let's see. And x-axis you have 2. In y direction just ignore 2, just only draw 1. In z direction just ignore the depth of beam and just insert 1. Clear? Grid spacing. So you see the spacing between x1 and x2 is 3 meter, and so basically you see that we need to define the spacing. Clear? So in x-axis we have only 3 meter, and in yy and in zz we don't need. Okay, so therefore just insert 6 meter in x direction. Okay, while in y direction just insert, you can insert let's say we try on 0, whether 0 works or not work. Okay, 0 not work, so just insert 1. Okay, and just insert 1. Okay, and ignore this and okay. So this is now the grid lines. Clear? Make xz plane, and this is now right your beam. Okay, so just draw by quick. Okay, and just click it. So this is your beam, and it must be 6 meter. You can see here, this is the distance from this origin point to this point is 6 meter. So you basically you read the dimensions from these x, y, z coordinates. Clear? So press escape. Okay, and now this is the beam. So we need to define joints. So sign, joint, restraint, and this is fix. Okay, we need to define loads, assign. The rest of procedure is same. Make it 0. Let's say this is 0. This is 0. Okay. Oh shit. Modify. Okay. And add to existing. You have a force. You have a gravity direction. And we will use, because the load is varying. Okay. So at distance 0, you see that you have a loading intensity of 12. But at distance 3 meter, this is your 0 point. Clear? And the distance is measured from this. This is your 3. Now at 3 you have a loading intensity of 18, and at 0 you have a loading intensity of 12. Okay, so let's say this is 12. This is 12, and at a distance of 3 meter, you have a loading intensity of 18 kilonewton. Okay, and okay. Oh shit! Why? Because we have 3 meter and we insert a total spacing of 6 meter. So that's why this is error. Okay, so now this is a problem for us. Let's see. I will try it with a different way. Pressing Ctrl Z, Ctrl Z, Ctrl Z. I just use the half portion of this beam, and that is this. Now you cannot able to to look at the midpoint of this. Okay, this is the midpoint, but the line is not in straight. So therefore here you can able to look at the midpoint. So this is the error. So let's see. We will edit again the spacing. Just click it and edit grid data and modify and spacing. Okay, and just edit this equals to 3 meter. Clear? And okay. So now your grids will be okay. Clear? Select it, draw a beam. Okay, draw a beam section. Okay, and remove it. Clear? Draw a beam section and now assign the support. Okay, this is support, joint, strand, and you need to assign fixed support. Now loading, assign, frame, distributed, make sure this is equals to 0. This is kilonewton meter. This is add to existing, gravity, okay, and the loading is okay. Okay, so this is the loading. Okay, now you are in position to analyze the structure. Let's see. Model do not run. Run now. Save it. Let's say this is project number 2, and okay. So this is the bending moment diagram. Let's see. We will this is 45 kilonewton and this is 63 kilonewton. Okay, let's see what will be the reaction. Clear? So 45. Okay, clear. Let's see. We will examining the shear force diagram. This is 45 shear force. Okay, I think this is okay. This is 45. Clear? And the moment is minus 63. Let's see. We will check it. This one. Okay. Press, frame, and moment about 33. Okay. And you have 63. If you want to check the moment right at this point, okay, just press the right key and you will see there. There is 63 in clockwise movement, and this is vertical direction. So this is the procedure that how we will analyze how we will develop a structure, a beam structure through grid line spacing. Okay, I think you will get a lot of information about grid spacing, that how we will develop. And next, inshallah, in next video I will trying to analyze a little bit complicators, to select a complicated structure. If you have any question, any doubts, please contact me. Your questions, your comments. Watch the video and enjoy. Thank you.